welcome to our exclusive talk sessions. Our next speaker is Roel Barstra from NEP, the Netherlands, and he will be talking about creating powerful storytelling and visual experiences. So the stage is yours.
Hello everyone, my name is Roel Barstra, I work for NEP, and together with the graphics department at NEP, we always try to create the highest quality graphics inside the Unreal Engine, composited of course in reality. This time around we try to utilize the ray tracing technology to enhance a dynamic experience. So a lot of people are talking about ray tracing right now, so we thought it would be a good time to actually explain a bit how the ray tracing works, how Unreal Engine handles it, how reality handles it, and hopefully you enjoy the talk. So what makes this very different from what we used to do in the past, some of you might have seen our work already, is the difference in how real-time this set is. So if you have a look around in this set, there's a lot of stuff going on here, but what's the most important part to take away is that everything is truly rendered in real time. So all the lighting, all the reflections, all the shading is all calculated every frame. So how is this done in the past? So usually real-time renderers use a so-called rasterizer, which means that every triangle in the scene, because everything around me is made out of tiny triangles, is it's calculated which pixels actually end up on the screen. And from that point on, it's kind of like compositing the image to give you the feeling that you're looking at a realistic image. But the problem with this technique is that everything you're doing is basically happening inside your view. So anything only works inside your view. This means if you look at the traditional techniques, reflections only act correctly within your frustum. And lighting is calculated inside your frustum, and anything that shoots back in a mirror and shoots back behind the camera or around you will actually just show a pre-captured image. Now the other important part is lighting. Lighting is really expensive usually to do, but in this set we show off like what real-time lighting can look like. So anything in this set is changeable utilizing the ray tracing technology. So in this case, we also wanted to show off how dynamic you can actually set up a set. So first of all, I want to say a bit more about the lighting in ray tracing, because you actually, when you look at these lights in real life, what happens is the light is bouncing around and it actually hits your eye, and that's how you perceive colors and the world around you. And what happens inside a ray tracing is exactly the opposite. It's you shoot from the camera and you bounce around until you hit a light. But this is really expensive to do actually. So it's only used in offline rendering techniques by film industry. So what Epic Games has done is actually make a combined render engine, so a hybrid render engine, where they first rasterize the image, so the triangles, so they know what the scene looks like in your view. And then for anything lighting reflection related, we actually go and ray trace the scene. This makes it really easy for us to actually tweak what parts we want to use from the ray tracer and actually optimize it in such a way that it's possible to utilize ray tracing technology at 50 frames a second in this case. So if you look in the reflections around me and in the car, we made this nice wind tunnel effect, so with colors and everything. If the camera would fly over the car, we can actually see that these lights are correctly reflected around in the reflections of the car. So this is all done correctly, but if the camera looks to a little bit to the right, in the cabinet, it's also showing right here the reflections of the Formula One car and the light trails passing over it. So what's happening is we're actually looking in a direction, all the rays will bounce in a direction that's clearly not visible for the screen, like the backside of the Formula One car. We cannot see it. We will be able to see it in this cabinet. Usually what would happen is reflections would just kind of fade in and out based on where you move the camera. This is what's happening right now in all virtual studios, because that's the only way that it was possible in the last couple of years. But now this set completely ray traced every light, every shadow, and every reflection. So you might be wondering, we have a huge setup here. So why is that the case? Well, what we've also been working on is our operational platform called Cube. And Cube is integrated in the Reality software to provide a more flexible way to operate in a scenario where we just don't know what's going to happen yet. So to give an example, we have these lights behind me, the light strips, the softbox on top, and the light to the right. And they're all now controllable on this DMX panel through ArtNet. And this is really cool, because we can now just move data from Unreal into our Cube platform, and then it's linked to ArtNet. And this is the cool part about this, is that we can just throw 200 lights in the scene and tell a guy who's really good at lighting, like, hey, make a cool light show. You know how to do this job. We know how to do rendering. You know how to do lighting. So let's work together. So we actually did this already for one show, which we unfortunately cannot show off here, but that's why we made this set, to show you that it does work in real time. And the coolest part is, together with the ray tracing, you will actually see all the reflections and lighting update in real time as well, which you need. If someone is changing the lighting, you also want the reflections to actually show you that the lighting is updated. And the cool part about DMX is it's just a couple of byte arrays, so you can do anything you want with it. In our system Cube, we script everything together using Lua. So if you get the DMX data, you can actually script it to anything in Unreal. So what's happening to the light right here, that's sitting on the top of these tires, it can actually be rotated around with the DMX really easily. And we hooked it up with a blueprint that actually handles this process. So we get the data, Lua sends it to a blueprint in Unreal, and Unreal is like moving the lights around. And we can also do anything with it. If you are familiar with level sequencer in Unreal, you can actually go scroll through the level sequencer using a slider. So this is actually very helpful for us to make a scene more dynamic for people that might not know Unreal. And you end up in a studio where you can make an installation, and everyone in the studio who has their job in the real world as a lighting guy can now have their job in the virtual world as well, which is really important to us. So that's basically what I wanted to show off.